As the quantum ecosystem is growing, there are more and more challenges that are popping up due to this growth. One of them is that if you are actually scaling your number of quantum system and quantum chips that you are selling, the number of tests that you are needing to conduct is growing. And if you are growing on the number of qubits, it's growing even further, and it's not very simple to actually test if all of your qubits are well functional. Today we are looking at a company that is aiming to solve this problem. The company is called Orange Systems, and with that, grab yourself something to drink and let's go right into it. So here we are on their website. It says QS up here, you see the logo, and it says, know your quantum chip, test solutions for better quantum chips. For quantum chips of several to hundreds of qubits, develop, benchmark and scale your next quantum chip with solutions from Orange QS. And then in the background we see this white box here, the people from Orange QS, and we see this chandelier here, which indicates that the qubits that we are talking about here are some type of solid state chip-based qubits, so probably superconducting or maybe also spin qubit type of chips. For sure, we are not talking about ions or neutral atoms here, because for those usually you are not using this type of cryostat. Then it says Orange Quantum Systems. So here we see, I guess, the different type of services and products they're offering. So it says Orange QS Max, increase your testing throughput for utility scale quantum chips. Then it says Orange QS Flex, get everything you need for fast and easy qubit diagnostics. Quantum Care, leverage our expertise to test your quantum chips. And then finally Orange QS Juice, open source operating system engineered for quantum R&D labs. Then it says industry and research. So I guess these are the two kind of customer groups that they have. On the one side, on the industry side, I guess the companies that are manufacturing quantum systems, but then of course also research labs that might want to focus on measuring those quantum systems rather than and running some types of algorithms on those and testing, let's say, the quantum information science things rather than testing the chips for their functionality. But let's see what it actually says here on the website. So on the industry side, it says, scale your quantum business. Orange QS automates your chip testing process, making it easy, affordable, and fast. And then on the research side, it says, develop your quantum expertise. Orange QS enables you to focus on interesting physics with user-friendly tools that evolve with the field. Why testing is important? Testing is a key step in a quantum chip development cycle. Integrated circuit-based quantum chips composed of superconducting or semiconductor-based qubits are delicate and susceptible to various sources of errors. These errors arise from factors such as thermal noise, electromagnetic interference, and imperfections in their fabrication process. Without effective metrology, inspection, and testing methodologies, these errors will therefore propagate and compromise the accuracy of quantum computations. Only a fast feedback loop between scalable design, fabrication, and testing will enable the large-scale fabrication and control of quantum chips. This development cycle is essential to pave the way to commercial quantum advantage. Now let's take a quick step out and take this a little bit apart. So first thing that we see here is we are talking about quantum chips. That's something that I've also briefly assumed before, mainly in the superconducting and in the semiconductor-based technology stack. So we are not looking at ions or anything from that side of the spectrum. The other thing that is important to mention here are the types of errors we are looking at. There's thermal noise, which can, for example, come from your cryostat, but it can also come from the filters that you are using in your electrical lines. There's electromagnetic interference, which might come due to some, fluctuations on your measurement lines, but maybe also from outside, because there's some radiation that is somehow making it inside. And of course, and this is a very important and currently also very, very harshly investigated topic, which is the imperfections in the fabrication process. So if you're looking, for example, at superconducting qubits, it's actually quite interesting. You are looking at a macroscopic system, more or less. So you can see the superconductors with your pure eye if you're looking at a chip. So these are not nanostructures necessarily, they are microstructures. Yet, on the other hand, they behave like a single quantum system when they're actually reaching the superconducting temperature. And this has some profound effects, of course. So that's interesting for being able to create those qubits. But then, of course, the exact properties of that system, again, they map down to the nanoscopic properties of how this circuit is actually being built. And there's, for example, a lot of research on different compositions of superconductors. There are different types of tunneling barrier materials being used, different etching procedures versus lithography procedures. You can use different type of wafer substrates. For example, in the semiconductor-based qubits, you might actually want to use isotopically purified wafer material, or you want to actually MBE, so molecular beam evaporate, or grow those materials on top to make sure that the quality, like the environment of your qubit, is very, very clean, like atomically clean. And these things, they all have an impact on how the qubit performance actually looks like. And if you want to measure that, for a single qubit, it's still kind of, well, I wouldn't even say easy. It's not easy because you have to make sure that like your whole setup is set up in a proper way, and it can take years to actually reach this point where, like, after you have manufactured the first qubit, you kind of clean up all your system, clean up all the wires and lines, signal lines and so on, to really reach the state where you can do a clean type of measurement. And then on top of that, so this is, let's say, the measurement side. On top of that comes now the complexity of adding multiple qubits together into one system. So if you're measuring a single qubit as a separate system, that's kind of a known measurement set that you are performing there. You're running through all of your measurements, and then you have characterized your single qubit. But if you want to do some type of quantum computation, if you want to do different algorithms, different gates on these qubits, you need to be able to not only have single qubits in superposition, but you need to entangle them. You need to entangle different qubits in different positions, and therefore you need to be able to tune these entanglements to make sure that they are coupled properly to each other or decoupled from each other. And that is, let's say, a very complex task, because suddenly the number of operations that you need to be driving is increasing quite a bit. And that's actually quite a challenge. And there's quite some research, let's say, needed, or quite some understanding needed in order to do that in an efficient way and to measure those properties in a proper way. So on the one side, you need the setup. On the other side, you need the algorithms and the signal processing and execution and measurements and the analysis of those. Coming to the next point here, so that was why testing is important. Now we look at why quantum chip testing is actually hard, and that probably caters to what I just said. So in contrast to conventional CMOS metrology and testing, no simple correlations exist between conventional optical inspection and information processing parameters of a quantum chip. The full performance of a quantum chip can therefore only be measured by calibrating and tuning up the qubits to levels of quantum computing operating conditions. Tuning up qubits requires a framework for executing physics-based control sequences and protocols that also allow for the automation of the task usually performed manually by experienced quantum engineers. Superconducting as well as semiconductor-based quantum chips do not operate in ambient conditions but need to be isolated and shielded, involving high vacuum, ultra-low temperatures, and low-power microwave electromagnetic signals. That also requires different methods of diagnostics, testing, and qualification as compared to standard CMOS metrology. Equipment for quantum chip testing therefore needs to consist of a control framework, room temperature control electronics, cryogenic input and output lines, ensuring DC and low loss microwave signal propagation, and a shielded cryogenic environment at millikelvin temperatures. So this is basically all of what I was pointing out before, and I think on top of that there's even more. There's like setting up the control electronics in the proper way. So if you are connecting, let's say, the pump of your system, the vacuum pump on the compressor that you need to reach those cryogenic temperatures to the same, let's say, to the same network, electrical network that you put your measurement electronics on, then you will have a lot of noise on that. So you also need to understand how to properly set up those very fragile control electronics that you have here. And on top of that goes, let's say, the filtering stages and all of that related stuff. So I think it is a very complex field to actually get all of these things done in a proper way, set up in a proper way. So what products do they offer? Our products make testing quantum chips based on solid state qubits easy, affordable, and fast. The Orange QS Max is turnkey equipment for high throughput testing of one or multiple quantum chips, accommodating several to hundreds of qubits per chip. The Orange QS Flex is a flexible system made for quantum chip R&D. It consists of an Orange QS Rack, a control electronic stack, and an optional fridge. It is seamlessly integrated with our quantum diagnostics libraries, a suite of software libraries for testing and benchmarking quantum chips. All products undergo extensive factory test and qualification. This ensures high quantum system engineering standards for the signal quality, connectivity, and tight integration between hardware and software for every product we deliver. And then there's the news section as per usual with some news down here. I'm recording this end of 2025. And we see these news are from December and November. So for example, here we see 11th of December. TeachLeap recommends a 4 billion euro investment in Dutch future of compute companies. Of course, there's also a newsletter which you can subscribe to and some information here on the company's values, which we will check out later, I guess, when we look at the company. The company is based in the Netherlands, in Delft, which I think is one of the, let's say, quantum hotspots here in Europe. Now let's quickly check out again on the products. We've seen them before. There's some more information about how the product actually looks like, and we are going to look now at, let's say, the flagship, which is the Orange QS Max, the next level in high throughput testing. Optimizing testing time and testing cost per qubit, the Max is designed for minimizing the overall testing time per qubit through its automation and protocols. In addition, because the Max is specifically built for testing, it has a much larger CapEx and OpEx than quantum computers and therefore a much lower cost per tested qubit. The Orange QS Max is a turnkey test system specifically designed for quantum chips, optimized for fast and efficient testing for your chip architecture. Once the chip is inserted and the fridge is closed, the Max automatically cools down, characterizes the chips, and generates a complete test report fully automatically. The Max platform supports testing of one or multiple chips simultaneously, with each chip capable of hosting over 100 qubits. And I guess here is some more information about that. Let's see. So computing, testing on quantum computer, computing, testing on fit for purpose system. Not sure if I understand that. Maybe as we read down here. So of course there's also a video, but I will not go through this as per usual. As the testing process is fully automated, only a single technician is needed to operate the system. This allows you to relocate 30 to 50% of your R&D team from designing, building, and maintaining test setups to focusing on core research and other high priority projects. With a delivery time of under 12 months, the max enables your team to begin measurements 1.5 to 2.5 years earlier than with a typical in-house build setup of similar size and complexity. And that's what I just said, right? It can take years if you have to kind of build those systems from scratch because of all of the stuff that comes with it, right? You need the cryostat, you need to set up the enclosure of the cryostat, you are setting up all of the, let's say, expertise in operating that and adding the electronics and making sure the environment is kind of clean. And here this really comes as a big white box that you put somewhere, and I guess it automatically has all of this know-how already baked into it. Then it says the Max is designed to minimize overall testing time per qubit through automation and streamlined protocols. Additionally, as a dedicated test system, it is significantly lower capital and operational costs than quantum computers, resulting in a much lower cost per tested qubit. Benefits of the Orange QS Max is turnkey quantum chip testing solution, automatic generated test report, test one or multiple qubits, quantum chips, capacity of 100 plus qubits per chip, and delivery times less than 12 months. And if you want one, you can contact their sales. Okay, so with that, let's maybe not go into the other ones to not make it for too long today. Let's quickly also check here on the news section. So what we've seen before was this news article here on the Tech Leap, but they were also present, I guess, here at this Quantum Needs You event and many others. So University of Cologne in Germany joins Orange QS Choose Better testing community, but there are also other news here. You see New York Quantum Summit, so very international, very global, and there's many more articles here available as well. With that, let's hop quickly into the About Us section to learn a little bit more about the company itself. So it says Orange QS delivers test equipment to create better quantum chips. Orange QS offers products to test quantum chip performance, creating the test equipment and protocols needed to obtain relevant information about this performance requires extensive developer time and expertise. Herein lies the bottleneck. Our easy-to-use tools provide our customers with fast and reliable testing of quantum chips. Our products are the result of a close connection between our proprietary testing protocols and carefully selected measurement and control hardware components. All these developments enable us to deliver industrial-scale quantum chip testing with high throughput. We understand our customer need when they set up a quantum chip development laboratory, and we incorporate relevant solutions into our products. Orange QS products help our customers iterate faster and smarter in quantum chip development. Orange QS was founded by, and then here you have the list of people that have been founding it as a QTech spin-off. So Delft, the founding team, contributed in different ways to the development and launch of the Quantum Inspire, the first publicly accessible quantum computer in Europe. Quick note on that one. I've actually used it very early on when it went online. It was very cool. It was a very cool experience testing out a quantum computer in a public cloud. I was so excited about it back then. I needed to also post about it because I had, let's say, used the one from IBM before, but somehow that Quantum Inspire one I even found a little bit more interesting because it happens like out in the open, right? Here is a little timeline about the company. So you can see, I don't know what these symbols here actually indicate. Maybe it's like an intelligence test, not sure. Looks like, you know, these tests where you always have to guess what the next pattern looks like. But no, I think not here because they're all looking the same. Okay, so launch. In 2020, the company was launched. The year Orange QS was launched. launch of Quantum Inspire, the first public quantum computing platform in Europe, and Quantify project with QBlocks as a partner. Then the diagnostics library was launched in 2021. Launch of quantum diagnostic libraries with the University of Cologne as the first customer. Launch of Orange QS Rack with Blueforce Finland, which has also been featured earlier in the Hidden Champion series. If you haven't seen the video, go check out the playlist on the YouTube channel as a first customer. Then launch of Orange QS Rack. EU-wide launch of Orange QS Rack. DPG Spring Meeting. So the DPG is the German Physics Society, hosting an annual meeting where not only researchers but also companies can present. EIC Accelerator Grant and VC investment. So they received some investment, I guess, and people joining their board. Then there's some launch of the Orange QS Max. That's what we've seen before, the product in 2024. And this year is 2025, which is and I guess when this is going online, it's 2026, which is the International Year of Quantum Science and Technology. IQM receives first Orange QS Max. Orange QS co-organizes SQA conference in Delft, and Orange QS closes a 12 million seed investment round. Partners of the company you see here, so there are like academic partners like the Technical University in Delft, but they're also part of the, for example, QBN, QEDC, which we've seen already before in a different series, and other networks. And then there's some information here about the investors. So we see IceCat Capital is the investment fund of IceCat NV and participates in disruptive ventures with a tech focus and global potential. IceCat itself is leading global provider of product data and AI-based content syndication services to e-commerce companies, manufacturing brands, and service providers. There's Qubit Ventures, is a newly established fund dedicated to early-stage investments in quantum technologies, primarily focusing on the EMEA region. They bring decades of experience in technology, venture capital, and quantum science. The team has over 100 years of combined experience in tech leadership and innovation, a deep understanding of quantum technologies, and an extensive network spanning academia, industry, and governmental sectors. There's the Innovation Quarter. Capital IQ is the regional economic development agency for the Greater Rotterdam, the Hague area. IQ finances innovative and fast-growing companies, assists international companies in establishing their business in the region, and facilitates international collaboration between innovative entrepreneurs, knowledge institutes, and government. IQ has more than 300 million in funds, so a euro under management. We fund disruptive startups, scale-ups that create a cleaner, smarter, and healthier world. High risk, but also high impact. And then there's also Cotton Technology Fund, is a venture capital firm that invests in early stage technology companies. The firm has a focus on deep tech startups in the area of clean tech, med tech, robotics, photonics, nanotechnology, advanced materials, and sensor technology. Cotton Technology Fund has an office in the United States and the Netherlands. The investment in Orange Quantum Systems is managed by the Cotton Dutch Seed Fund vehicle, which includes financial Dutch government support from RVO. Current and prior investments include Scorpius Technologies, Sarcos Robotics, Exagen, Biotech, Sancure, Infinitum, Electric, and so on. I'm not going to go for all of these now. And then finally, last but not least, backed by Quantum Delta NL, QDNL participations will invest 15 million into early stage Dutch quantum computing startups in coming years. The QDNL participations fund provides the bridge between the grant giving phase of research and the patient capital phase of venture investment. QDNL participations provides impactful business and commercial support to transform potentially great technical ideas into obviously great investable companies, helping brilliant technical minds organize leading talent to bring their ideas into the world for the benefit of humanity. So now you've also seen a couple of those investors here. Quickly to the values. So there are some brand values here. One of them is quality, innovation, cooperation, and reliability. Besides that, there are also the core values, and that's what we've seen on the original page, and that will be also the closing now, which is the mastery, adaptability, teamwork, and honesty part. And with that, I hope you honestly liked this video. If so, make sure to leave it a like. If you don't want to miss out on the next one, make sure to subscribe, and always make sure to stay hydrated. I'm looking forward to see you in the next video. Until then, bye bye.